students, myself Geetanjali Harwande from Rayat Shikshan Sanstha's Mahatma Phule Arts, Science and Commerce College, Panvel. Today we are going to learn an important and interesting point, that is transformer, from our 12th physics, that is electromagnetic induction. In this chapter, the working of transformer is given, and it is based on principle of mutual induction. So what is principle of mutual induction? Whenever there is change in magnetic flux linked with the coil, an EMF is induced in the neighboring coil. As magnetic field created and magnetic flux linked with one coil changes, then EMF is induced in second coil. It means that we require two coils, and it is known as mutual induction. So for mutual induction we required two coils. One is primary coil and second is secondary coil. So for working of transformer, basically first we have to know the use of transformer. That is, transformer is an electronic device which is used to change the voltage of alternating current from low to high or high to low. Means when we apply low voltage, transformer will convert it into high voltage, and when we apply low voltage it will convert into high. So basically it transfers and contain constant voltage. So transformer, it uses primary coil and secondary coil. In primary coil there are number of turns rotated, and here secondary coil there are number of turns of secondary coil. They are around a rectangular frame that is known as iron core. So what is iron core? They are soft iron core, means soft slides like the pages in a book. They are bounded together. Here also there are number of sheets, plain sheets, they are bounded together, which is known as iron core. The iron core's first main working, its main part is that it isolates the two coils from each other. So its main function is to isolate the two coils from each other. So in primary coils there are number of turns, there are specific number of turns, and secondary coil also contains some number of turns. These number of turns in the primary and secondary coil, they are denoted by N. So NP is notation for number of turns in primary coil, and NS is the notation for number of turns in secondary coil. Now, according to our principle of mutual induction, when we pass input current in first primary coil, when we pass current through primary coil, we know that when a current passes through conductor, it will produce magnetic field around it. So due to this magnetic field, there are change in magnetic flux, and it passes through this iron core towards the secondary coil. So in secondary coil there is change in flux. Flux is denoted by phi, and change in flux, that is denoted by d phi by dt. So there is change in flux in secondary coil due to the current pass in primary coil, and due to change in flux there is production of EMF, that is E. So there is production of EMF due to change in flux. So that is the basic principle in this transformer. So here the words which are here mentioned by red color, they are very important. when we pass AC voltage supplied to primary coil, a magnetic flux change link with iron core, it changes and this magnetic flux or change in magnetic flux link with this primary coil will produce the EMF in secondary coil. So here phi is magnetic flux in each coil in each turn. Means in one turn magnetic flux is phi. There are number of turns in primary, that is NP. There are number of turns in secondary are NS. So total, that is total flux in primary coil NP is nothing but the flux in one coil into total number of turns. So total flux phi P equal to NP phi. Now similarly the total flux in secondary is given here, that is NS equal to phi S equal to NS phi. So these two are total flux in primary and total flux in secondary. Now by using these two equations and by using the Faraday's second law, what is Faraday's second law? Whenever there is change in flux, EMF is induced. So here the EMF is induced, that is EP equal to d phi by dt, and if we substitute the value for phi p that is equal to phi p means np into phi, as np are number of turns in primary are constant, we taken it outside, and so here EMF in primary equal to NP d phi by dt. So here we have substituted for value of phi p. Phi p is NP into phi, and this NP is taken outside, that is here, and only there is remains d phi by dt. So similarly ES, that is EMF in secondary coil, is given by, instead of NP here number of turns in secondary. So this is equation 1 and equation 2. If we divide equation 2 by equation 1, equation 2 by equation 1, we will get here ES divided by EP to the left side, and to the right side we get this d phi by dt will cancel out and we get NS divided by NP. So dividing equation 2 by equation 1, we get this important equation ES, mean to the left side there is ratio of EMF secondary to primary, and to the right side there is ratio of number of turns in secondary to primary. Means here we can say that the EMF produced in secondary coil is directly proportional to number of turns. Means as number of turns we increase, EMF will greater. If number of turns are less, EMF will be less. So that important equation, this very important equation is known as turn ratio. Means number of turns, it gives ratio of number of turns NS divided by NP. So it is known as turn ratio or transformer ratio, or it is simply known as equation of transformer. It is simply known as equation of transformer. Again further, if we take the formula of power means it is nothing but EMF into current, EI. So for input power and output power, input means where we gives the input, that is along primary. We give input along primary. Here there is a iron core and here there are secondary. So in primary it is act as input, and in secondary this is act as output. So for input power we have to take consider the primary coil, and for output we have to consider the secondary coil. So ES, divide this EP to the right side, then ES divided by EP, and to the left side IP divided by IS. Here EMF in secondary and current in secondary, they are inversely proportional. Means in first equation EMF and number of turns are directly proportional, but here EMF and current, they are inversely proportional to each other. So we have two equations here, equation 1 and equation 2. So combining these two equations, both the equations have same left hand side, LHS is same, so we can equate the RHS of both the equation, and because of combination of these two equations we will get final the equation as ratio of EMF equal to ratio of number of turns equal to ratio of current, but current is inversely proportional. Means if we increase number of turns in secondary, it will increase EMF in secondary, it will decrease the current in secondary. So by using this equation, there are two types of transformer we can construct. First one, if number of turns in secondary greater than number of turns in primary, then as EMF is directly proportional, if number of turns in secondary are increased, EMF will increase, but the current in secondary will decrease. So if number of turns in secondary increase, means number of turns in primary and number of turns in secondary, if number of turns in secondary are greater, the current in secondary will less. It means that we can increase the number of turns in secondary increases. So this type of transformer is known as step up transformer. Because here number of turns increase, EMF will increase, but current will decrease. Means if we want less current, then we have to use, if we want less current in output, we have to use step up transformer. Second type is if number of turns in primary are greater, means number of turns in primary are greater than number of turns in secondary. Means number of turns will decrease, then EMF in secondary also decrease and current will increase. So here number of turns and EMF goes on decreasing, so this is known as step down transformer. Thus by using step up or step down transformer, we can change the EMF or voltage from high to low or low to high by using this transformer. So transformer simply used to regulate the voltage as required. Means if we provide sometimes the voltage will fluctuate, then if we provide voltage of 200, means less voltage, then it will convert this 200 into 230 volt as required by using step up transformer, and if there is greater voltage in primary, it will reduce it to 230 volt by using step down transformer. So this is step up transformer to increase the EMF or voltage, and this one is step down transformer to decrease the voltage. So we can regulate the voltage by using the electronic device that is known as transformer. As it is important point from the point of your exam, so there are many more questions asked for 1 marks, like what is transformer, or simply state the principle of transformer, or any two factors on which the maximum value of EMF is depends. Then there are some more questions asked for 2 marks also. like what is transformer and describe only construction with help of neat label diagram. Frequently asked question that is very important, that is for 3 marks. It is asked many more time in your exam. Derive expression for EMF and current for transformer in terms of turn ratio. So we have to calculate here turn ratio. Then 4 marks question, that is combined question, state principle of transformer, also construction, working with diagram, and calculate or derive expression for the ratio of EMF in terms of number of turns in primary and secondary. So students, this is all about the transformer, working of transformer. If you have any doubt, you can ask us by using our number. My number is 9763 87731. Thank you all for listening me.